do we deal with elements when they don't have the expected oxidation state? In particular, let's take a look at this example right here. The expected oxidation state for nitrogen, since it's group 5A, it would gain 3 electrons, making it -3 anion. So we'd expect -3. What we're going to find is more times than not, nitrogen is not -3. Like here, we have nitrogen oxide 3 different times, but it doesn't make sense because they're all different. They're actually very different compounds. So we need to give them different names. Even identical twins, we give different names to so we can tell them apart. Here we have nitrogen and oxygen, and you notice there's only one oxygen in this formula. If you crisscross, you'll see that it's N2O1. Here we have nitrogen and oxygen, but this time we have 3 oxygens and 2 nitrogens. That's a completely different compound. And then we have here N2O5, again a completely different compound. So we give them all different names. Can't name them according to the previous way of simply name the metal and then name the non-metal with IDE in the end. We have to use some special systems, and there's 3 different ways we're going to use it. The IUPAC naming system, which is the international naming system for chemistry, is pretty easy. It will take the oxidation state of the first or positive element. In this case, usually it's a metal. And so the metal, or the cation, would be named, and then you use a Roman numeral to indicate its oxidation. So this is easy. Nitrogen, Roman numeral 1, see, oxide. This has a +3 charge, so it would be nitrogen, Roman numeral 3, oxide. And then we have nitrogen, Roman numeral 5, oxide. This Roman numeral indicates the oxidation state of the metal or the cation that's listed first. The second way to name the elements that have a multiple oxidation state or an unexpected state would be to use Latin prefixes that indicate the number of each element that we use. And here are the Latin prefixes. They're not hard. You know most of them. Mono means 1, monograph. Di means 2. Tri means 3, triangle. Tetra refers to 4. Pentagon, hexagon, and so forth. 5, 6. Okay, let's take those same compounds that we used before, but let's name them different. If I did it before, the charge is +1, so I would name this nitrogen, Roman 1, oxide. But when I use the Latin, I indicate how many of each I have. Notice I have 2 nitrogens. So dinitrogen monoxide. Dinitrogen monoxide. Here I have 2 nitrogens, dinitrogen trioxide. Dinitrogen trioxide. It tells me how many of each I have. So literally, I can derive the formula from this name. 2 nitrogens, dinitrogen pentoxide. I can derive the formula from the name. The third way is a little more difficult. In this option, it's mainly for the transition elements, which are the elements that are metals in the middle of the periodic table. They change their oxidation all the time, so we just automatically assume we're going to give them a special name. And that special name indicates what the oxidation for that element would be. Okay? And it's really just a matter of memorizing. If you look on your periodic table, the first oxidation number listed for any one of those elements, we're going to rename that element with an OUS on the end. So for instance, here's copper over here. Copper has at least 2 oxidations. It actually has more than 2. But we look at the first one. Since that's the first one listed, we're going to call this cuprous. See how we changed copper to OUS? Cuprous chloride. 1 copper with 1 chloride. Okay, cuprous chloride. Now you could keep going. You could call it copper 1 chloride because it has a +1 charge. Copper has a +1 charge. And then you can name how many you have. We have 1 of each, mono copper, mono chloride. The second copper listed has an oxidation of +2. So if we put it into the formula with chlorine now, it actually has a different formula. The second oxidation listed for any of the transition elements, we will give it the name ic on the end. So copper becomes cupric chloride. Again, if we use the oxidation number method, it would be copper, Roman numeral 2 chloride, because copper has a +2 charge. And then the amount of each, I have 1 copper, monocopper, I have 2 chlorides, dichloride. And there's a whole list that you can practice on. The first oxidation number of the transition metal will end in OUS when you name it. The second one would end in IC. And here are ones that these all have the Latin prefix for the most part. So mercury becomes mercurius chloride or mercuric chloride. Iron, which is actually ferrium in the Latin, would be called ferrous chloride and ferric chloride, and so forth. When we name the polyatomic ions, we name them as is. We don't change the name at all. We don't have to do anything fancy, whether they're listed first or second. So like here you see ammonium. You just look this up on the polyatomic ion chart, and there's chlorine. So ammonium, and then change chlorine to chloride. This time the polyatomic ion is listed second. So we have aluminum, just name it as is because that's the metal listed first. Phosphate is listed second, just name it as is, aluminum phosphate. Copper, nitrate, again, because copper is a transition metal, we need to give it a special name. And in this case, copper has a +2 charge. You can see if you crisscross it here, it'd be +2. And if you look up nitrate, it's -1. So if we indicate one name, would be copper 2, and then just name nitrate as is, copper 2 nitrate. That 2 means that copper is a +2 charge. If we use the Latin prefixes, we'd have 1 copper, monocopper, and 2 nitrates, dinitrate. And if we use the us and ik method, copper +2 is the second oxidation listed, so we would call it cupric nitrate. There's a whole set of rules for organic molecules, but we're not going to worry about them till we get to organic chemistry.